Hi, everyone. Welcome to our very first episode on the mini topic of science versus pseudoscience. To lead us into this journey is Dien Ho. Dien, maybe you could introduce yourself first, and then we will go from there. I'm really interested because I guess to begin personally, one of the things I do ask myself quite a bit is, am I being sufficiently scientific in my own work? And I think
Right.
it's very important to me. And there's a question of, is it easy to demark between science and pseudoscience? Should this word even be in our vocabulary, or is it
Right.
just simply a useful thought practice? But I guess first you'll introduce yourself, and then, as you said in our previous things, you promised that within 15 minutes you can tell us three easy criteria by which to quickly demark between science and pseudoscience, and then we'll be set from there. So, yeah,
Yeah, and I'll take care of world peace right afterwards.
sweet.
So I'm Dien Ho. I'm a professor of philosophy and healthcare ethics at MCPHS University, which used to be called Mass College of Pharmacy and Health Sciences. It is, in fact, the oldest school in Boston, Massachusetts. And we beat out Harvard on technicality. Harvard is officially in Cambridge. So we are, in fact, the oldest school in Boston. And my research is in philosophy of medicine, philosophy of science, healthcare ethics, bioethics in general. In addition to teaching, I also perform clinical consultation in hospital setting for ethics committee. So prior to joining MCPHS, I was at University of Kentucky. I helped form their ethics committee at the medical center. So the question of science versus pseudoscience has been fascinating to me. I recently wrote a book called A Philosopher Goes to the Doctor. And part of it is to actually look at some of the hidden assumptions that clinical and research physicians engage in when they practice their respective profession. So I think the distinction between science and pseudoscience is obviously important given the context of science. There are two things that immediately stand out. One is just from a practical point of view. There's a huge amount of money involved in scientific research, and of course the resources dedicated to providing scientifically substantiated medical treatments, for example. Medicaid, Medicare in the United States doesn't cover any alleged treatment. It merely covers those treatments that it deems to be effective and also arguably scientific. So just because something might work, it doesn't necessarily get the coverage that a well-established scientific treatment can receive. So just from a practical point of view, there is a lot of money at stake. But there's also a philosophical issue, which is that science for us is in some respects special. We all know that phenomenon. If you want to lend some legitimacy to what you're doing, all you need to do is have someone put on a white coat, talk more sciencey. You watch a commercial, and if there is a person selling you a skin product and there's some molecules flying around and it's based on stem cell, and there's a doctor somewhere that said this stuff it's magic, it all of a sudden gains certain legitimacy.
And scientific magic. It must be scientific magic.
Absolutely.
Yeah.
Absolutely. It's not just any magic. That's got to be some sort of a smoke screen to make you think that it is science. And I think that reflects our at least cultural deference towards science. And there's a lot of reason to think science is great. And historically, I think, at least in the 20th century, there has been an attempt to find out exactly what is so good about science from the point of view of epistemology, of knowledge. Is science as a practice special? Does it give us beliefs that are more likely to be true? Is it more rational than other ways of understanding the world around us? And these questions, of course, requires that we first identify what is the method of science, and secondly, determine whether science actually deserves the kind of epistemic virtue that we attach to it. So for me, the distinction between science and non-science or pseudoscience, it's practically and philosophically important.
Well, and I guess on that very first thing you brought up, you said your demarcation is between science versus pseudoscience. And I guess one of the other things that gets wrapped in there is like, is it science and then science comprised of good science and bad science, and then
Right,
there's pseudoscience on top of that, and then there's also, of course, completely non-scientific
right, right,
claims and non-scientific issues as well. And then I
right,
guess there's also where do you put the spotlight? Are we putting the spotlight on the behavior of scientists, or are we putting the
right,
spotlight on the subject domain,
right.
or the behavior of the group? And
Those are all great questions. And let me start with the first one. Pseudoscience is not just non-science, because there are lots of things that are non-science that we do not immediately think of as pseudoscience. Um, for example, making pottery. If you like to throw pottery, that is a practice, but no one would intuitively think of it as a science or pseudoscience. It's just not either one of those things. Pseudoscience, on the other hand, has, in my opinion, has a veneer of looking like science, but it's not science. And I think it is really a legacy of some of the earliest attempts to define what science is. So by the late 19th century, early 20th century, with the progress of Western science, I mean, really tremendous progress in Western science if you look at the history of science. During that period of time, you also see the rise of a number of different disciplines that look like science, but has has the veneer of science. But a number of scholars notice that there's something missing here, and it is those the disciplines that appear to be scientific but are in fact not scientific, that gets the term pseudoscience. So one classic example is spiritualism. Spiritualism, not just in terms of the idea that you believe that maybe there's something bigger than all of us in the universe, but rather that the literal spirit, the soul, for example, can be folded in and studied as a part of scientific discipline. So there's a well-known headline from a New York newspaper showing that a physician in Massachusetts was able to measure the weight of the human soul as it departs the body. And that approach to me is a kind of scientific looking approach.
yeah, actually, I think is that one of the ones where they looked at like it was basically just as the person died, they essentially
Yes.
measured the difference in the mass, and it's
Yeah,
like, I
absolutely.
mean, not to take a turn for the vulgar, but like we all know what happens right after a person dies. There's definitely some matter leaving their body at that
Right.
point in time, and I'm pretty sure that's not soul.
Yeah. And his sample size was incredibly small. I think there was something like 6 people he measured, and they were all EB patients. He also measured the weight of dogs before and after their death to see if there was a difference. And he concluded that there was no difference. So dogs did not have soul and people had soul. So that to me is a classic example of kind of pseudoscience. And you can practice pseudoscience with all your conviction that what you're doing is actually scientific. So you don't have to be kind of a quack or trying to scam people, although there are plenty of people who do that by practicing pseudoscience. You can be a genuine scientist or genuine believer of what you're doing, but yet be practicing pseudoscience. And there are, of course, like in between areas that we don't know if they're science or not, but they look like science. So political science, why do we add the word science to the study of politics? I think partly to lend some legitimacy to the process.
Yeah,
Um,
yeah. Actually, as you mentioned that, because I think one of the things is on that very topic when you said beginning, people were trying to lend legitimacy to certain topics by using the word science, and so, for example, the term social sciences.
right,
The idea was, and this is I would say a noble and reasonable approach, or say we're gonna. We know these social phenomena. We know that they're difficult to quantify and study. And so what we're going to do is we're going to take these methods and these principles that we've learned from other scientific domains, and we're going to apply them to social phenomena. And so, on one level, that seems completely legitimate. Like that seems like if you had to choose a path to go down, that seems like a good way to do
right,
it. At the same time, then when the legitimacy gets flipped on its head, we're saying, oh, these things are as certain as they are the lab sciences or what's happening in a particle collider. And
Right.
so essentially, there's the aspiration towards rigor, which is always good, and versus, are we actually going to pretend that these things are known and measured with the same replicable certainty as other topics?
Right. Right. So if if we, for any discipline that strives to be more scientific, first and foremost, we have to know what it is to be more scientific, and that requires us to actually define what science is, and that really has been the penultimate goal for lots of philosophers in the early 20th century, among the positivists, of course, from the Vienna Circle. They really look at the growth of scientific progress and ask, what is it about what these scientists are doing that is so effective? Let's distill the methods and see if we can export it to other areas of human inquiries. And that, to me, is the heart of the matter. It's not so much delineating science from pseudoscience, but what makes science special? Is it something intrinsic to the logic and the practice of science, or is it more to do with sociology and the structure and the system of scientific communities in general?
Yeah, and I guess maybe to add another one on top of that, or is it just some aspect of like the natural construction of the universe where it just so happens that, just the physical reality of
Mm-hmm.
things lets us get away with it. Like if we act generally in this way, that
Mm-hmm.
that happens. So I guess when you talk about what are the traits of science,
Mm-hmm.
one thing that comes up is, it's sort of like that with the Potter Stewart thing. It's like I'll know science when I see it, and also
Yeah.
like pseudoscience. Like I know it when I know it when I'll see it. And I guess maybe one of the useful takeaways, just to make sure people get that out in the beginning, is like,
Yeah.
is there a science? This is science if and only if X,
Right.
or this is pseudoscience if and only if X. Are there
Right.
necessary and sufficient criteria for these things?
Man, that's the key question, and you see that at least in the early days, attempts to provide necessary and sufficient conditions for what qualifies as science. So the earliest attempts were, I think, really derivation of something that Francis Bacon was doing much early on. That the idea that what makes science is that science is sensitive only to evidence provided by nature. So if you can understand the logic of science and nature supplies the evidence via observations or experimental results, whether as a scientist you like it or not, your hypothesis is either supported by the evidence or it is not. And I think that view that scientists' personal biases, personal hopes and wish is ideally distinct from the relationship between, say, a hypothesis and its supporting evidence is still very much in our zeitgeist today. You hear some of the more popular scientists who do a lot of public engagement. They will tell you things like, the great thing about science is whether it's true, it's not up to you. It's up to the universe. And that, I think, had been the dream of those who tried to discover the underlying special quality of science. And the earliest attempt in the 20th century was verificationism. The idea that what makes science is that its claims were subjected to verification by empirical evidence, and pseudoscience and non-science make claims that are not subjected to the tribunal of nature, as they would say. That move turned out to be far more complicated than most scholars initially thought. As intuitively attractive as that is, one obvious problem is that there are lots of claims that are exceedingly difficult to verify. So is the science require that we actually verify a claim before we call a claim scientific? Because if that were the case, too many claims in science would be non-scientific. So it must be something like we can verify it in principle. But then what do we mean by verify in principle? So how we have to spell that out. But also, if all that is that makes science, it's too easy and too hard for something to be science. So take astrology. Astrology is something that we typically think of as non-science. But if you do any diving, any shallow diving into the astrology domain, you see that there are sophisticated theories, models, and so on in the literature. It looks kind of like science. If all it is for science to be science is that it's exposed to evidence for evidential support, then all an astrologer has to do is to make one prediction. And if the prediction is true, great. If it's not true, great. Because what we care about here is not whether the discipline is a true science, is an accurate science, but whether it is science at all. So you can have bad science, you can have unreliable science, and still be science. So astrology could easily become a science just by making one, two, or a handful of empirically verifiable predictions. And next thing you know, it qualifies as a science. And on the opposite end, there are too many disciplines in what we consider science that do not obviously generate any verifiable consequences. So, for example, theoretical physics is a classic case where we're like, it's really hard to come up with some verifiable experiments that can test variants of string theories, for example, or like how many dimensions there are. How do you actually make that determination from an empirical point of view? But we don't want to rule out theoretical physics as a science a priori just because they might not generate obvious verifiable results. And the same can be said for computational linguistics, for observational science, where you're just measuring, for example, the water temperature of the ocean. You're not really making any hypothesis that has to be verified. You're just collecting data. All those disciplines would have a hard time qualifying as science if all we care about is verify evidence.
Yeah, that's really interesting. I guess there's a few things I wanted to unpack there. Because first of all, there's a question of, I guess, is it called I think there's a term called formal sciences, which is essentially the scientific topics that are more just like extensions of formal logic.
Right.
And I'd say, for example, mathematics is one of those where questions like, is mathematics a scientific field, or is it simply an extension of logic as is? And, obviously, in our guts, we don't really want to throw out mathematics as a scientific field because it's so rigorous and it's deductively true. And, it especially coming from a statistical background, we really, really don't want to throw out mathematics as one of those cool things. At the same time, its methods are a bit distinct because, whereas scientific claims usually are, for example, subject to the problems of induction, where mathematics, even mathematical induction, is actually deductive.
Right.
And maybe that's the only thing we can get them on, but
right.
Yeah. So, but I guess there is that element where does, like, for example, like deduction play into this? Another similar example is like the reason why we don't throw out a good theory just because it's contradicted one single observation. I like to bring up the example Pythagorean theorem. Basically, anyone can prove it on a piece of paper.
Right.
No one could actually take out a piece of paper, draw a triangle, and actually get it right. You'd be wrong. You'd be error. And we don't throw it out because there's a deductive truth to it. Similarly, I guess, like interplanetary motion. I think before like Neptune was discovered or something, it was creating elliptical orbits of other. Well, it's always been doing that.
Uranus.
Yeah. And so essentially, we didn't throw out the theories around planetary motion simply because there's something that we hadn't observed and put in the equation yet. And that's would be considered bad science.
Yeah, that's right. And, I think the question of formal science goes further than just looking at mathematics and so on, because even in some of our beloved science, quantum mechanics and relativity are probably the two pillars of modern physics. And we still look at those and, there are plenty of places where two models, two theories can have identical empirical consequences. But we don't think of that possibility as, well, then it's not science because they're not making any empirical differences. Einstein had a choice whether he wants to proceed with a Riemannian model of his relativity, where space is considered curved, or you can go with a Euclidean space, but then add universal force to it to actually make everything add up. both models save the phenomenon, so to speak. Both models are compatible with what we know. So if what we care about are empirical differences, then there's a sense in which this distinction should be meaningless. But yet we do think it's meaningful. And Einstein chose it for reasons. He went with the Riemannian system for reasons that really were more pragmatic. It was more elegant. It was easier to do the math. So let's go with I'll go with the Riemannian one. But whether or not, that to me is a part of scientific practice, those kind of consideration. And the falsifiability, the idea that, what makes science is that in principle can provide observations that can be shown to falsify your hypothesis. And this was, of course, Karl Popper's famous theory that until today is still very much infused in how many of us think about science. As a side note, the reason I wrote my book on medicine and philosophy is because I went to a talk probably 4 years ago at Harvard where a well-known geneticist made a remark. He said, of course, what I'm doing here is not falsifiable, so I don't consider myself a scientist. And I really thought to myself, how could this possibly be? Because anybody in this room is a scientist. Is that guy right there? So this idea of falsifiability, I think, came out as a reaction to the problem with verificationism. And it's precisely because the logic of induction, according to Popper, was too nebulous. We don't have any real good formal system, at least not on par with deductive logic when it comes to inductive logic. So what Popper thought was, hey, I don't have a logic as to why finding a ton of emeralds that are green gives me confidence that all emeralds are green. But I do have a logic that says if I find a red emerald, then I know deductively that it's false that all emeralds are green. So he went with this deductive approach because of the certainty and the development in deductive logic. So for him, a science is a science just in case it generates results that can conflict with the scientific hypothesis. And for him, things like astrology would not be a science because, as you know, if you just open a page of the newspaper and look at astrological predictions, they're usually so vague and so soft that practically anything could happen to you the next day, and it will be at the very least consistent, if not in support of the prediction from yesterday.
Yeah, actually, as you're saying that, the main thing that popped in my mind, you said when someone opens up the newspaper to read their horoscope, the weird thing to me was, wait, people still open newspapers?
I just betrayed my age.
Yeah. So maybe just to quickly unpack this, because I know that we've used quite a few terms and people might not be as familiar with them. There's the idea of verificationism, and which was then, I guess, supplanted or amended.
Yep.
The next step on that was then deductivism, and then by Karl Popper. And so I guess verificationism says that, obviously things, in order to be scientific, we need to be collecting evidence for them. They need to be evidence-based, that hypothesis needs to be verified. The problems cropped up with that. It was rejecting too much that was acceptable as science. It was letting in too much that was not acceptable science.
In addition to the fact that we don't really have a well-developed inductive logic, the relationship between evidence and hypothesis remains exceedingly difficult to pin down exactly what is that logical relationship. Yeah, and it's really with that dissatisfaction that Popper appealed to deduction and offer his verifiability as the criteria for science.
Yeah, and I guess maybe just one quick example of that is, for example, like if I pick up this pen right here, you could say that obviously there's some physics behind me picking up this pen, but alternatively, equally coherent with that evidence is that I'm simply moving my hand and there is an invisible demon grabbing that pen and moving it at the same time. And we can't extract those. And there's no reason to believe that there isn't at least some universe where there is actually that demon who's just, following everyone and picking up those pins for them.
The term of art in philosophy is underdetermination. Yeah. That the evidence we have underdetermines the hypothesis. So given a finite amount of evidence, it is compatible with infinitely many hypotheses. So why should we pick one over any one of them?
Mm-hmm. So now I guess then we move on to deductivism. So basically the idea that your idea should be falsifiable. People brought up examples. I think you actually, you mentioned to me in a correspondence that Freud is obviously brought up quite a bit as as someone who his theories could not be falsified themselves, although actually in his own practice he did rigorously amend his own theories and work on them that way. But again, the idea that if we're just simply going to have falsifiability, that again it seems like it was again not sufficient because it rejected legitimate scientific practice. For example, the heavenly bodies moving around in their elliptical motion. It would have thrown that scientific practice out and would have kept other things that we would think are again the astrology, where you you simply reject all of your you propose and are wrong in all of your astrological forecasts.
And it would be a science, a lousy science, but still a science.
And so,
and I think what to me what Popper was holding on from the earlier legacy of the positivists, and Popper is oftentimes known as a post-positivist, but he held on to a spirit of the philosophy that the earlier positivists also felt, which is that to see whether something is a science, all you have to do is look at the internal rules of inference within the science. How does it function? And somehow, if we can identify the rules, the logic of the science, then we can decide whether or not a particular discipline is a science. So if I know all the permissible rules of inference within astrology, I should be able to examine astrology as a discipline and decide, without ever interviewing a single astrologist in my life, whether that is a science. So that kind of focus on the logic and the semantics of a discipline, it's, to me, a leftover from the earlier positivist approach. And Popper clearly held on to that, because for him, you can tell whether something's a science by looking at whether or not that discipline entails predictions that can be shown to be false. If the answer is yes, then it's a science. If the answer is no, then it is not.
Yeah, that's I guess one of the little caveats or asterisks in my mind that popped up was like, it's sort of interesting because essentially he's saying, like, we can examine the rules and the operations. Like, we basically find the handbook of this scientific domain. If you flip it open and you read rules 1A through 28B, we actually know how these things are operate, and that's how these people work as little automatons and perpetuate the scientific field. And obviously, like, the fact is, like, these rules don't exist. There's plenty of mushiness in them. A lot of it is laden with subjective evaluations. But one of the things I think is sort of interesting and what retains its value is the idea that he still is basically just saying, show me it and I'll tell you what it is.
Right.
And so essentially his hard and fast rule doesn't work, but he's still effectively using the same method that we're still using today, which is show me the thing and I'll give you a verdict.
Absolutely. And also, really, up until Popper, no one, including Popper, no one actually bothered to look at how science is practiced in the field. So you have a whole bunch of philosophers who are, to be fair, familiar with science, but they weren't, by and large, scientists or practicing scientists. So as a matter of fact, if you're going to try to define a discipline, it seems obvious in hindsight that we should at least try to capture how science is practiced in the field. And once you start doing any exploration of the actual practice of science, the history of science, then you notice things like, the famous Leverrier and Adams discovery of Neptune really came from observation one evening when Leverrier, using Newton's laws, was unable to locate Neptune at the Uranus at the correct location. So if you were a Popperian, if you believe in Popper, Newton just made a prediction that Leverrier has falsified, and you should reject deductively the hypothesis.
Yeah, it means Newton is wrong. Wrong. Done. He's done. Yeah, like, cast him out of science.
A good scientist is one that deductively rejects the hypothesis, and you're done.
Yeah.
But what Leverrier did, and this is what made him a good scientist, was that he actually asked himself, I wonder what assumptions I'm making here. And one of the assumptions that he made was that there were only 6 planets, that there was not a 7th planet, and Uranus was the last planet. So he thought, what would happen if there was a 7th planet that was yet to be discovered, and that planet's gravitational field was pulling Uranus away from the predicted orbit? And he calculated the orbit, he calculated the mass of this alleged planet, and it wasn't until, I believe, 2 years later when they were actually able to identify, to actually see that planet. And that planet was Neptune. So what it showed was that when we test hypotheses, we never test them in isolation. We test them in conjunction with assumptions like there are only 6 planets, or that my telescope is clean, or that I'm not drunk, or that light does not bend in a funky way on these evenings. All those assumptions are built in when we do any experiment. When the experiment comes out with a false prediction, it doesn't show that the hypothesis is necessarily wrong, but rather it shows that that huge mess, there is something rotten in there. And if that's true, then Popper's dream that what makes science is that a hypothesis can be falsified. It's just false. It couldn't be, because we never actually falsify hypotheses by themselves. And this, to me, was an extremely important realization that science doesn't have that kind of clean internal logic that Popper was getting at.
Yeah, and I guess just to sort of bolster the fact that this isn't just an interesting historical note, but this is actually really useful. There's a lot of data scientists and statisticians who listen to this podcast. Actually, I'd pretty much say the only people who listen to this are data scientists and statisticians. But it's really part and parcel what you just described with how we actually practice in many things. So, for example, there's a huge drive to get people to get people that are technical skill set to be predicting things. We'll just call them things. Like, you choose a topic, we'll give you some data, just predict things. And the problem with that is, we are testing a lot of, for example, models to see which ones are best at predicting. But there are more components to it than just an individual model. And there are layers upon layers of like deductive and inductive leaps that we do. And what I think is interesting is that when in practice, I'm not going to get this like perfectly eloquently stated, but the idea is there are times when we have to guess, like, are our data predictive? Is there enough data to actually make this prediction? Like, is there literally just enough things that are available to make a useful prediction? So, for example, something that might be irreducible could be using the current polls to forecast elections. The current ones that they're done in the way that they're done essentially seem irreducible, that they can't actually get them to be accurate the way that we want. But there are other places, for example, in clinical medicine, where you might say, which is also a very noisy place, I'd say clinical practice is, it's not scientific in the form of replicability, the type of replicability you'd want in a lab. There's there are other scientific aspects to it, but for example, the replicability is very hard. But the question is, like, is there enough data in here that you get a smart, hardworking person to be able to predict something of interest? And when one method falls in their head, they might say, oh, well, this doesn't work anymore. They might be like the astrophysicist who just says, I've just rejected this, I can't go any farther. Or they can say, no, I'm going to stick this out. What are my assumptions? And I'll line up the assumptions and say, what is being violated here so that I can make progress going ahead? And I think that's one of the things I've really seen, especially in the biomedical field. What really separates like good data scientists and the productive data scientists is their ability to quickly sort through, okay, what are my assumptions? Where are things going wrong? And also, what is rock solid that I don't need to check that anymore? So these aren't theoretical things. I think they are, people sometimes think that, philosophy is this abstract thing that we're dealing with. And like, we need to focus on practical problems, and philosophy is too abstract. I kind of have this, I'll just shoot out a hypothesis to you that, like, in data science and statistics, we are actually, the problems that we want to solve are practical, but we're dealing with abstractions in order to deal with them. Like, we're fundamentally dealing with abstractions of this real practical thing, and that these philosophical underpinnings are in fact extremely practical for the abstract. And so I know that's a little bit weird and layered, but I guess it's
no, you're absolutely right. You're spot on. I mean, this idea that a good scientist is one, and in fact, it's not really about science per se, but it's whenever you evaluate the failure of an idea, you have to try to find where was that broken link, where was that problem, and with medicine, with predicting an election and so on, there are so many moving parts. In fact, one can argue that infinitely many moving parts. To be able to identify roughly where you think the mistake was require certain instinct that Pierre Duhem, a far earlier French scientist, said requires certain level of scientific sense. And of course, that's just another word for magic sauce. We don't know what the magic sauce is. But somehow, and I have a deep deference for science, somehow scientists are better at this than coin toss. So there's got to be something going on here, and we don't know exactly what that is. That, to me, could be part of the magic of science, or it could be the institution of science, how we do peer review, how we check each other's work by replication, how we funnel in incentives, and maybe that's the magic. But what is clear after Popper, once you start looking at the practice of science, you realize that science is far less internally clean and logical than we think. And it wasn't really until Thomas Kuhn's work, and Thomas Kuhn, as everybody knows, is probably the single most important thinker when it comes to the nature of science in the last 100 years. The Structure of Scientific Revolution is one of the greatest books ever written. And it pains most philosophers because he wasn't even, technically speaking, a trained philosopher. He was a scientist first and foremost, and he wrote a brilliant philosophy of science book. And in it, he argues that what makes science is essentially the existence of a paradigm, that there's a set of core principles. There are individuals' case studies that we want we want each other to emulate. There are peripheral problems that most scientists spend the bulk of their time trying to solve. But what they're not doing is challenging the foundational core beliefs. And once in a long while, some recalcitrant problem becomes so difficult that we were able to ignore them, brush them aside, and say, hey, don't worry about that. Like one of my favorite examples is trying to reconcile quantum mechanics with relativity. We know they can both be true, but good luck trying to write a dissertation on that, because your advisor is going to tell you work on something else. That's not a worthy problem. You're not going to get a job with that. So we are allowed to push aside some problems as being anomaly, but once in a while, those anomalies just refuse to go away, and it gains steam enough that people eventually start questioning the entire paradigm, and you have a scientific revolution. And one of Kuhn's insight is, if you look at the history of science, why we went one way as opposed to another in the face of a revolution, they have oftentimes not been guided by any rational deliberation. It's like, how come the French Revolution succeeded, yet the Tiananmen Square protests fell miserably? There are oftentimes no rhyme or reason. It could be that some person was at the right place at the right time, or that this revolution had a nicer and glossier brochure. Who knows?
So, I mean, in science and scientific issues, it could just be a person of sufficient intellectual capability is sufficiently frustrated with the contradiction of the previous paradigm. And at that point, they're like, okay, time to just kick this pebble off the cliff and see whatever avalanche it creates.
Right. And if you look at the history of science, like, the Copernican revolution, one of the fact that you will notice is Copernican revolution gained steam before that heliocentric view was actually able to make predictions that were on a par in terms of accuracy as the older geocentric view, the Ptolemaic view.
Yeah.
So it couldn't be like, man, that ship is sailing straighter, but rather that ship is all over the place, but I'm jumping over there anyway.
Yeah. So just for people who might not be as familiar with this, it's the idea that essentially when we had this a heliocentric one versus a geocentric one. So I guess maybe people think of this as essentially a Ptolemaic view on one side and a Copernican view on the other. That what people don't realize is that actually the observations at the time were actually extremely in favor of this sort of geocentric view.
Right.
What they could actually view with their little angles and their measurements and their telescopes and everything. This was actually like the evidence was actually on the old belief. It wasn't with this heliocentric theory, and it required people essentially more steam to build up until they're eventually like, all right, we're going with this one. And there's other reasons not to do it too, like you'd be burned alive for believing that and things like that.
Right,
so,
exactly.
It's just like it's like the punk rock revolution of that I guess early mid Renaissance period where they just said, yep, this is where we're going. One thing I guess you've set up our trajectory for two things that I really want to cover before we go, because we have about a little less than 20 minutes left. Is when we examine these issues, so two things. One, obviously, you talked about revolution and Thomas Kuhn, and the idea is that there are essentially there are certain values laden in scientific beliefs, and either those create tensions or they relieve tensions. They can give people the intuition that they need to have that separate secret sauce. Like the fact is, like a good scientists are generally they're very intuitive, and whether that's a deductive intuition. For example, I've noticed that the best lab scientists are really excel at inductive intuition. Whereas I've seen a lot of, for example, successful data scientists, what they really know is they have a good intuition around the problems of induction. And I'm sure someone will come on and correct me on that one, but still, that these scientific processes that there's values laden under them, and that's what helps you advance. But at the same time, what I want to get at was the trajectory, which was that there's also just human activity. So the idea is like when we're looking at whether or not something's scientific, we can look at the field, we can look at human activity, we can look at a group of human activity, we can look at a theory versus a theory plus data, and we can say this data is not scientific. And so maybe that should be something where we should go over a bit, like where do we go after the theory? Do we go after the person? I like going after the person, not only because I love ad hominem attacks, but because basically,
underrated.
Yeah. They're never overrated. But the idea is like, that's the one that I can always ask myself though. Like I'm saying, like, am I being sufficiently scientific? Am I being as rigorous with myself as I can be? Because obviously I can't convince other people, but I can save a lot of my time in my day-to-day, type D type job by being as scientifically rigorous with myself. So how do we weigh out those things? Where do we focus? Should scientists be basically looking internally, or should we be looking internally at ourselves in our own practice as scientific versus is this field even scientific?
Right. So I think that question depends on what it is that we ultimately think makes science special. If we hold out for the hope that science is special because of some epistemic virtue, that it does deliver more true beliefs than not, that it gives reliable and consistent results, it helps us discover the structure of the universe. You want to be more poetic. Great. We can go that route. But if we go that route, then we have to look at ourselves and our biases and ask whether or not they are standing in the way of that pursuit of truth. That, I think, is it's a straight out simple recommendation. Our system set up to encourage the challenge of our hidden assumptions. Are we dogmatic so that we are holding on to beliefs because of some reasons other than what is warranted by our criteria? If Kuhn is right, then in some respect, science must be dogmatic. We're not challenging foundational beliefs all the time. But yet, of course, some of the greatest progress ever made in the history of science involved challenging some deep, dogmatically accepted belief. So the function of science, I think, in every day-to-day operation, you can't afford to be a scientist today, a professional scientist, and get paid. You have to be able to pay your bills, take care of your family, and so on, while spending all your time in a lab challenging whether electrons exist or not. You're not going to get paid. So the system of science, it really behave a lot more like what Kuhn suggests, which is we're just solving problems on the peripheral and not really looking at a deep problem. For me, if you think science is special because of its epistemic virtue, then I think it pays to be mindful of our biases, our assumptions, and be open to the possibility that we could be fundamentally wrong. And that, to me, is the lesson of Popper and also the lesson of positivists. We like to believe that what makes science science is because, at the very least, a necessary condition, maybe not a sufficient one, is that scientists are willing to give up their most treasured beliefs in the face of good arguments and good evidence. Whether in practice that's true, I think that's a different ballgame. You can also try to justify science as being pragmatically special. What makes science special is because it has delivered good things to us. We can communicate with one another. You and I having this conversation right now because of the progress in science. No question about it. Medicine has done some amazing things. So we can say science is special because it has delivered the goods. But of course, if we go that route, we have to ask ourselves, what kind of goods has science delivered? And are these actually things that we want? That question cannot be settled by scientists. That question can only be settled by all the stakeholders who are affected by the practice of science. And that is not because we are some bleeding heart liberals. We want to make sure that everybody's voice is heard. But rather, if we're going to decide whether or not this business that we're paying for is in fact doing the things, delivering the goods, whether these contractors are remodeling our bathroom, the least we can do is tell them, how do we like our bathroom? Right?
Yeah, that's that is a very good point. Also, just the basic cognitive load of handling all these things. As we said, we can't say, even figuring out these the most I guess narrow focused scientific phenomena. It's very difficult, and then say, and now we're going to apply it out to the rest of society, and that bit's the trivial bit.
Right.
It isn't.
Right.
That isn't there. And obviously, people. I'm very much in favor that people should get some bang for their buck out of science. I like to hope that my own employers find that my salary is worth the cost,
right?
And that they find that valuable. I guess two places that I wanted to go from this, and I guess I will let you decide which one. The first one was, and this goes back to a little bit. Well, we'll talk about the first one. Do you want to go and talk about essentially the values of moving science forward, or in what values that place? Option number two, and I actually thought of a third thing on the menu. Option number two, do you want to talk a little bit about scientism? And again, we've mentioned before that there is essentially a resurgence in this belief of people saying, oh, science is the thing that's objective. And essentially, it seems that there's a lot of issue where people are conflating what I would consider, like, I do fundamentally believe that the phenomena that we study are largely objective. And I don't, I mean, obviously there's some wiggle room around that, but the idea that are the phenomena that we study objective versus the people studying who are subjective, and I think that gets conflated far too often. And it brings in really bad verbiage, like calling things pseudoscience, when essentially it's just shaking the cage a little bit. And the third one that I want to talk about, are obviously that we could mention, was scientists are this has come back to the Kuhnian revolution thing. Scientists are fascinated with the people who cause scientific revolutions. And although most of us are effectively practicing what they'd be called normal science. So we aren't trying to revolutionize science. We're just fiddling around on our bit and trying to make some progress on that. And, obviously there's a lot of progress that's made by normal science. So essentially there's this dichotomous view where we really celebrate the revolutionaries, but most of us ourselves are normal scientists. And that's the actual term, normal scientists, that Kuhn used. And that bit, like, what makes good normal science is frequently neglected because it's people so busy trying to find the new world that they forget, wait, how can we be focusing in ourselves and be a better scientist ourselves?
I think that you're spot on, man. Those are huge questions. I'm going to see if I can lump the second and the third one together, because in some respect that's kind of in my research mission. I try to do as much writing and research that appeals to the public as possible, and it's important to be familiar with the state of science, like how certain are we in medical research? How is it funded? Are basic bench science results being replicated? And if you look at these questions, you realize that we are actually setting up a social context of science that doesn't jive with what we say science should be doing. So, for example, most researcher in medicine can tell you there is no glory in doing replication studies. You don't get tenure for that. You don't get published. I think a number of well-known journals have openly said we prefer primary research over replication research. So who is actually keeping the score? Who's actually doing the hard work in the background? And slowly, with the replication crisis, of course, being a classic example, but if you just take the most basic look into medicine, you realize, man, a lot of basic biology research hasn't been well confirmed. And that could be the reason why pharmaceutical companies have such a hard time going from phase 2 to phase 3 clinical trials, is because a lot of these assumed pieces of data turn out to be wrong. And that I don't take to be bad scientists practicing bad science. I take it to be, it's systemic. We have created a system that rewards home runs and rewards revolutionary magic bullet solutions to our illnesses. And that obviously would discourage people from actually doing the very important work. So regardless of whether you believe that science study the world out there or not, one thing we should be clear is we have some values about what science should be able to do. It could be epistemic, it could be pragmatic. We need to make sure that our institution of science actually line up with those values. And right now, at least in the case of medicine, that is not true. That is simply not true. And of course, as we are in the middle of this pandemic, I think one thing that behooves us is that we are all looking for salvation. We're looking for saviors to get us out of this mess. And science, of course, has been a critical part of this. But it's also extremely easy to be blinded to the fact that they're not the only one who can help with the problem. A pandemic, by definition, is a social problem. If we all live in bubbles and in isolation of one another, there is no problem. So understanding the virology of COVID-19 is just as important as understanding the social connections and how our society is put together such that we're vulnerable to this kind of contagion. That kind of myopic view of looking at science as the only path of salvation has historically been common, but it's extremely important for us to back up a little bit and see that there is worth in other parts of our understanding of the world that can contribute to solving these global crises.
Well, yeah, I think that is a very good description. And I think one of the most important things to bring up here is that there's nothing wrong with scientists critiquing scientific process. In fact, that is fundamental to the scientific process.
Right.
One thing that I've been really disappointed with as far as like coverage and discussion of these things is that anytime someone questions a scientist or brings up critiques of scientific nature, that they are essentially having either they're mincing their words so that they don't basically create this conflict, or alternatively, they are running the risk of essentially being called, science deniers, not in science, anti-science, simply because they're coming from another domain of science, which might be the more relevant domain. And so I think that there is this issue where the ability to have these critical conversations is in fact a symptom of good science. It is not a roadblock. And I think people are so desperate for good scientific results at this point in time, because obviously it means that whether or not we can go out and use the playground again, that we don't want to hear any possible bad news or critique or anything like that. We just want, there's so much uncertainty and stress that we don't want any more uncertainty with these things. And so I think that is sort of corrupting the conversation. And that is a purely social phenomenon right there.
Yeah.
Obviously, that's not created by the nature of the universe. That's created by humans making human considerations for their own human social status and things like that. We have a few minutes left before you have to go. Should we do any final words or final thoughts? What would you like? The criteria, the one if and only if criteria, criterion. Which what was it?
Let's turn to the back of the textbook and see what the answer key says.
Yeah. It's you show me, and I'll tell you.
I am too uncertain as a philosopher. Of course, I feel like I'm uncertain about everything. That's kind of exactly. It's kind of the professional hazard.
You won.
But if I were to say, if I were to give a speculative gut check kind of definition, necessary and sufficient condition for science, I would say something along the line that science is the practice of trying to understand the empirical world with shareable methodology, transparency, and evidence that we can collectively evaluate, that we can challenge the most fundamental and dear beliefs. Nothing is off the table. To me, that is, at the very least, a big chunk of the necessary condition of what makes science. Maybe it doesn't get us the whole thing, but if you get rid of those in your practice, if you say you need to sign this piece of paper such that no matter what you discover, you're never going to deny this claim, I say you're not practicing science. So in that respect, it's contrary to what Kuhn said, that science is necessarily in some respect dogmatic or conservative. I think what makes science so special is the willingness to be wrong.
Yeah, I like that a lot. I like the idea of that nothing is off the table, that there are essentially the boundaries can be moved. I'm not saying that we don't regularize against those, that there isn't some resistance against those things. We don't let ourselves be blown to the wind by evidence. We don't let ourselves be blown to the wind by deduction because, our deductive faculties are limited in many ways, which is something that every math undergrad learns immediately.
Right.
But, the idea is that we don't get blown to the wind one way or the other. But at the same time, if the wind's strong enough, we will move in that direction. And I do like that very much. Also, the way that you describe that, it can help encompass both individual behavior, group behavior, and also, the idea of like whether we're talking about theories and evidence and things like that. That I like that because it can essentially, no matter how you want to dice science versus pseudoscience versus bad science, however you want to say, are we putting the microscope over individual behavior versus group behavior? I think that that's a good standard. So, Dien, thanks so much for your time today. I appreciate it.
Oh, it's been a pleasure.
Hey guys, it's Glenn. Thanks for your time today. I hope you liked today's episode. If you did, please consider smashing that like button. It's the single, simplest, fastest way to make sure that YouTube shows this video to more people. If you really want to go crazy, consider subscribing or going to our website and joining the mail list. We won't go totally crazy beyond that. Forward this to a friend or colleague who you think might enjoy this too. We're a small channel and every bit helps. Our next episode will be coming out next week, so in the meantime, feel free to look around the channel and see other videos that might be of interest. As a quick disclaimer, the views expressed on the show do not represent anything other than the people saying those words, views, etc. like that. It doesn't mean anything about their employers or their employers' views or some thing about their employers or their neighbor's cat or anyone else not saying the words. And in fact, given that people tend to change their views when they're thoughtful enough, it might not even represent the views of the speaker by the time you're hearing the episode. So definitely come back and see if they've changed their views at a later date. They also don't represent the views of our sponsors. Thank you to our sponsors. You can check them out on our website.